Morning, this is your stats sensei, Mr. Spensei, and this is a warm up on the empirical rule and normal distribution. The weights of adult golden retrievers in a dog park are normally distributed with a mean of 70. That's important. So we know we have a mean equal to 70 and a standard deviation of 5. Label the mean and standard deviation as well as the z-scores. Be certain to include the percentages used with an empirical rule. By now, we should be in pretty good shape with that, but please remember the for the z-scores, all z-scores have a mean equal to 0 and the standard deviation is 1. So this is going to be 0, 1, 2, 3, -1, -2, -3, and technically the normal curve goes theoretically to negative infinity all the way to positive infinity. And I'm going to go ahead and put a z down here just to remind us that these are our z-scores as opposed to our actual values. Well, plus or minus 1 standard deviation for all normal curves is 68%. Plus or minus 2 for all normal curves, not anything else, but just normal curves, is 95%. And plus or minus 3 standard deviations for all normal curves, regardless of the mean and standard deviation, are 99.7%. But once again, the empirical rule only applies to the normal curve, but it applies to all of them. So this was our mean, and we wanted actual values as well. Well, they tell us our standard deviation is 5, so we have a 5 basically going between each one of these. And they told us our starting point was at 70. That's our mean. So this is 75. 70 plus 5 is 75. 75 plus 5 is 80. 80 plus 5 is 85. That's our 3 standard deviations above. So if you had a golden retriever that's 85 pounds or more, it's 3 standard deviations above in weight and probably a fatty. All right, taking away 5, we're at 65, 60, and then all the way down to 55. Probably a little bit skinny and unhealthy at this weight. Use the scenario above to do the following. Draw and label the graph for each question. Calculate the probabilities and box your answer. What percentage of the dogs weigh between 60 and 75 pounds? So we're looking for the probability that a dog is 60, which is less than X, which is less than 75. Well, what was that? Drawing our graph, our mean is at 70, but we wanted it all the way up to 75 and all the way down to 60. And we're looking for this area right here. And this happens to be my lower bound. This happens to be my upper bound. So when I go about this, I'm going to have a norm CDF, lower bound of 60, upper bound of 75, mean of 70, and standard deviation of 5. So this is my lower, upper, mean, standard deviation. Second vars, normal CDF, lower bound 60, upper bound 75, mean of 70, standard deviation of 5. We end up getting 0.8185. What percentage of the dogs weigh less than 60 pounds? So we want the probability that 60 is less than X. So if I'm drawing my picture, it's going to look something like this. We still have a mean of 70. That's our mean. We want the probability that it's 60 or less. So 60 is going here. We're shading this way. Always goes to negative infinity. So this is my lower. and this is my upper. So norm CDF, lower bound of 60. Oh, excuse me. I shaded to negative infinity, lower bound of negative infinity, upper bound of 60, mean of 70, standard deviation of 5, because that's what we've had the whole time. Second vars, normal CDF, lower bound negative 9 raised to the 99th, upper bound 60, that's what we shaded to, mean of 70, standard deviation of 5, and we end up getting 0.0227. What percentage of dogs weigh more than 85 pounds? Wow, that's three standard. We were looking up here. If I look up here at my graph, that's three standard deviations or more. That's not very many of them. It's going to be a small percentage. Probability that X is greater than 85. So when I draw my picture, we're still looking for a mean of 70, but we're looking at 85 and we're shading up to positive infinity. So once again, norm CDF, the lower part of my shading is 85. The upper part of my shading is positive infinity. My mean is 70. My standard deviation is 5. So lower, upper, mean, standard deviation. Second vars, normal CDF, lower 85, upper 9 raised to the 99th, mean is 70, standard deviation of 5. And I get 0.00134. Pretty small amount. Approximately how many of the 50 dogs at the park weigh between 60 and 80 pounds? Well, first off, I need to calculate my probability. And to do that, we need to set our probability statement. We want the probability that the dog is 60 less than X less than 80. Oops. All right. Now I could use the empirical rule. And by empirical rule, I'm expecting about 95%. Now we're going to use a calculator and get a more exact or more precise percentage, but I could have used empirical rule and been pretty close with that. So in this case, our mean is 70. We're looking from 60 to 80. This is my lower, this is my upper. So I'm shading in between there. And so I have a norm CDF 60 less than 80, and our mean was 70, and our standard deviation is 5. That's still our LUMO. And let's go ahead and run that so we can get our probability. Second vars, normal CDF, 60, 80, 70, standard deviation of 5. Oops. And we end up getting 0.9544, pretty close to that 95%. This is a more precise measurement. So now I need to figure out the probability. Well, I'm going to need that value right there. And it's going to be, oh, we have 50 dogs. So what's the probability that X out of 50, so X over 50, equals 0.9544 over 1. So we're going to multiply these two values and divide by the third. So I'm just basically multiplying by 50 times 50 and dividing by 1. And I can get, oh, about 47.72 dogs. 0.47, oops, 47.72. So about 47.72 dogs weigh within that range out of the 50. That's most of them. All right. How many weigh between the 65 to 70 range? Well, we're basically our probability statement is going to be this. What's the probability that the dog is 65 is less than X is less than 75? So once again, we're setting this up. I have to do the probability first. Let's draw a picture of what this is going to look like. Well, the picture is going to look like this. We're centered at 70. And this is going to be 65. And this is going to be 75. We happen to know that this is plus or minus one standard deviation, so we should be pretty close to 68%. All right. So norm CDF, lower part of my shading is 65. Upper part of my shading is 75. Mean is 70. Standard deviation of 5. That's my LUMO, and I go ahead and label it this time LUM, the standard deviation. Second VARS, normal, CDF, 65, 75, mean is 70, standard deviation of 5. And we end up getting about 68%, which is what we knew we would get. So this is 0.6826. We knew we'd get about 68% because that's plus or minus one standard deviation, and by empirical rule, we can say that. All right, so that takes care of that first part, but it didn't ask us for the probability. It wanted to know how many out of 50. So we're going to have to go back to proportion. So X out of 50 equals 0.6826 over 1. I'm going to multiply the two numbers on the diagonal and divide by the third number. So 50 times 0.6826. Just multiplying these two numbers, dividing by 1, and I get about 34 dogs. Keep writing 0.34, 34.13. It's 34 dogs. All right. Hopes that helps. Hope to see you on the next one. Thanks for watching.